Okay, this is again your question paper of 3 marks. What they said in the question, for the network shown, the switch is closed on to position 1 at t equal to 0. Okay, so at t equal to 0, the switch is connected to position 1. Let's draw the circuit side by side. What they mean, right? If the switch is connected to position 1 means no connection to position 2, so the circuit would look like. Then they said, then move to position 2 at t equal to 1.4 millisecond. Means if t is equal to 1.4 millisecond, then it was connected to circuit 2, position 2. So the diagram looks like this, right? So can we consider that is it t equal to 0 and this is t is greater than 0. Now they said current in the inductor when t 2.5 millisecond, right? So 2.5 millisecond is after 1.4 millisecond, so that would be the t is greater than 0. Now as you can see, for this particular circuit there is no supply over here, so this condition will be the discharging condition, right? Would be the discharging thing. So as you know, the discharging equation is IL is equal to I naught raised power minus T by tau, correct? Now we need to calculate tau. As I told you, how can we get tau? Tau will always get it at T greater than 0, correct? So T equal to 0 switch is this, T greater than 0, the switch is connected like this. So tau formula is what? L divided by R. L is how much? 10 millihenry. 10 into 10 raised to power minus. R is how much? The combination of 2.5 and 2.5, that is 5. Correct? So that would be 2 into 10 raised to power minus 3. We got the value of tau 2 into 10 raised to power minus. Time they have already given. Time is how much? 2.5 millisecond means 2.5 into 10 raised to power minus 3 again. We need to calculate I naught. I naught is the current across inductor. That would be for this circuit. Okay. So let's redraw the circuit, because as I told you, if there is an inductor, then we need to short circuit the inductor, then only we'll be able to find the current, right? That you have already calculated. I would be equal to how much? That is 10 divided by 7.5. 5 plus 2.5 is 7.5. So the current across inductor would be how much? 10 divided by 7.5. Correct? Now they said determine the current inductor. So the final equation would be 10 divided by 7.5 e raised to power minus 2.5 into 10 raised to power minus 3 divided by 2 into 10 raised to power minus. So this would be cancelled with each other. So it would be 10 divided by 7.5 e raised to power minus 2.5 divided by 2. You can solve it further, then you will get the final answer.